Yep. So remember, there's three ways to show that two triangles, prove that two triangles are similar. The first one was the angle-angle similarity postulate. That was in the very last lesson that we did. The first way for this lesson is called the side-angle-side similarity theorem. That's what it says up there at the top, side-angle-side similarity theorem. So here's the picture of the theorem. I think the picture helps a lot more than the actual words do. It says, if an angle of one triangle is congruent to the angle of another triangle, so this first part here is saying that if you have this angle here congruent to that angle over there. So two angles are exactly the same, congruent, okay? And the sides including the angle are in proportion. So this side is in proportion with this side, and this side is in proportion with this side. If the two sides that include the angle are in proportion, that's what that means here, the sides including the angle are in proportion, then we have enough to say that the two triangles are similar by the side-angle-side theorem.
Wait, does it have to be both?
So you can put side-angle-side similarity in the proof if you've shown that your sides are in proportion and you've shown that the angle is indeed congruent. Then you say the reason, side-angle-side similarity. Alright, the third way to do this is the side-side-side similarity theorem. And the picture again tells more than I think the actual words do, but we'll connect them both right here for you. Okay, if all three corresponding sides of two triangles are in proportion, then the triangles are similar. Now it's important that you actually check all three. So corresponding sides need to be in proportion. So if I highlight this side, the 9, 15, and 18. First of all, 9, is that the smallest side of that triangle? Then you should match up that one with the smallest side of the other triangle. Which one's the smallest side of that one? Because a lot of times the pictures are not going to be drawn the right way. Okay? So the first one I'm checking is this. So I have a 9 over 12. Okay? Then I want to check a middle one, and then I want to check the big one, the large one. So go to the largest one now. What's the largest one of the little triangle, the largest side of the little triangle? 18. So go to the largest side of the other triangle, 24, and check to see. Okay, this one is, so I have an 18 to 24. That should have been in green, sorry. Okay, then the only other leftover part is 15 to 20. So that goes in the middle. Okay, now you have to check and see, are all of those in proportion? That's what this is saying. So how do we reduce 9/12? So what's it reduce to? 3/4. How do I reduce 15/20? So what does it reduce to? 3/4. And then 18/24. So therefore, all three corresponding sides are in proportion. All three of them are. And we found them by matching the little side to the little side of the triangles, and then all the way around. So therefore, we have enough to say that these two triangles are similar by the side-side-side similarity theorem. Okay, here's two triangles. Are they similar? Okay, well, here's what we're going to do. We're going to match up the corresponding sides. So go to the smallest side on the triangle on the left. What's the smallest side for the triangle on the left? 20. What's the smallest side for the triangle on the right? 10. Very good. So I'm going to write that down, okay? I'm going to say 20 to 10, okay, equals that. So then go to the biggest side. What's the biggest side on the left? 30. What's the biggest side on the right? 18. Okay, so I'm going to go ahead and write that down again. So 30 to 18. Okay, and then what about the other one? Okay. We'll go green. We'll go 25 to whatever's left is 12. Okay. So what do you guys think? If this is 25 and this is 12, let's reduce all these. See here, 20 over 10. That's 2 to 1. Is that the same thing as 25 over 12? No. Is it the same thing as 30 over 18? No. So are these similar? No. These are not similar. All three have to be in proportion. There you go. Automatically. Okay. So these are not. So not all triangles will be. Okay, Iman, you're up next, buddy. Okay, are these similar? They sure don't look like it. There. I just did freehand drawings there. So well, let's see here. The triangle on the left. Let's match up. What's the smallest side? 50. Good. What's the smallest side on this side? 40. Don't let your eyes deceive you. Yep. Okay, so we're gonna line up what we've got. We're gonna do some investigating. So I'm gonna go 50 to 40. Good. I'm going to leave a space, and then I'm going to go to the largest one. What's the largest one on the left? 60. Largest one on the left? 50. There we go. Okay. So, write that in. Where am I at? 60 to 50. Okay. Okay, now, what else do I have? What's left? Yeah, 55 to 44.
Yeah, wait. No. No, it's 5 over 4 equals 5 over 4.
Okay. 5 over 4 does not equal 6 over 5. Very good. So these are not similar. So what's it going to take for them to be similar?
They all have to equal proportion.
All three have to be in proportion. Very good.